Hello, Bio3 students. As promised, a little video tutorial on this week's lab. The content itself, talking about diffusion, is not terribly complicated, though it may not be intuitive. There's definitely introductory material in the lab itself, and you can also use your textbook or other resources if you need some more information. But what I've got here is your lab notebook, and I really want to spend time talking about the graphical analysis program. And so when you go to your physical processes of cells, and the computer has been tragically slow, this is just telling you where it came from. These are the topics we're going through. And there are some additional resources. Several of you mentioned in the lab discussion that providing the PDF for the virtual microscope actually caused more confusion than was helpful. So that's just a reminder that these sorts of documents go into a lot more detail, and they may or may not be helpful to you. They are not a part of the lab, but this came with the online lab. The introduction goes over, it says that students will use the probe data. So we're not actually conducting the conductivity experiments that would detect the rate of diffusion of molecules across a membrane. We will have a description of how the experiments were performed and then have the data to analyze. So we will look at the effect of the concentration on the rate of diffusion, looking at 3 different concentrations of a particular solution, and determine this last part I'm actually not going to be able to do because that data disappeared from the program. So there is the background about diffusion, what it is, how we can measure it, what the setup would have looked like. The pre-lab assignment are questions you should be able to answer before digging deep into the data, so it lets you know the concepts that you're going to be dealing with. So this purpose of the experiment, answering the questions, and here I did say that you do need to make your answer look different from the font of the question, so you can use a different font, you can use boldface, you can italicize, you can highlight. And all of that is possible when you click on that little edit pencil. You can make it bold, italic, underline. You could change the font here. You can highlight here. And I'm not going to edit this because it looks as I want it to. But I did highlight where there are answers that need to be provided. The procedure is the description of how diffusion rates were measured using a conductivity probe, because we were looking at the diffusion of sodium chloride across a membrane. And sodium chloride is an ionic compound, so that when it is put into water, it dissociates into its sodium with a +1 charge and chlorine with a -1 charge. And then we can use the conductivity of those ions to detect the rate of diffusion. And so the first thing you see, you're going to need some manner of a computer device and the graphical analysis for app or program. I already have this, but I will click on it so you can see what shows up. If you are on a laptop or a desktop that uses Windows, versus the Mac OS, which is what I have, an iOS mobile device or an Android device. So that is how you would get the actual program. And then when you'll be using this, this is telling you how the experiment was set up. Watch out for the green boxes that say there's something for you to do. So in table 1, predict what you think will happen. And the tables are all at the bottom. I'm going to delete table 4 because we don't have that data. But the first one is to make a prediction in table 1. and a question for you to answer. And so you should answer it right here. Go into that editor pen and provide your answer in this space, making sure you use that highlight, different font, bold, something to make your answer stand out from the sea of texts that I have to read on this page when I'm grading. And that's telling you how the tubing would look, how they did it, and then you're going to determine the rate of diffusion. It says to select the data in the most linear region of the graph, apply a curve fit, select linear, etc., and record the slope in table 2. In order to do any of that, you're going to need to scroll until you get to the data. And here's where I eliminated that effect of a second solute on the rate of diffusion because the data disappeared from the data set. When you click on the data set, it should open the graphical analysis program. I just downloaded it. There's my graphical analysis program. Scoop that up. We're not going to data collect. We're not going to manually enter. You need to choose the file that you just downloaded. And that is the membrane diffusion. And it's already got the graphs on here. So it tells you that the y-axis is the conductivity. The x-axis is the time. And now we've got these 3 graphs that don't, since there's no title or anything else, if you click on this, it tells you what our data sets are. You could rename or delete the data set. We don't want to do that. If you click here where it looks like a little graph, get the graph legend, and now we can see that the red indicates the 10% sodium chloride, the blue is the 5% sodium chloride, and the weird green is the 1% sodium chloride. So that is our legend, which we should have on there. You also, the legend statistics, it did say to, let's do the edit the graph options. You should always have a title for your graph. You may pick a different one, but that's what I chose. The effect of the sodium chloride concentration on diffusion rate. Back here, it said you wanted to get a curve fit. And you want it to do linear. Oops, linear. And you can apply that. And now you get your equations of your y equals mx plus b to get your slope. Your slope is going to be the m. So for the 10% sodium chloride, there's your slope. For your 5% sodium chloride, there's your slope. And for your 1% sodium chloride, there is your slope. So you're not going to have to calculate. It will give you those data. And if these aren't showing up, if you click in this weird little triple box that is view options, you could look at just one graph at a time, 2 graphs at a time, 3 graphs at a time, or you can also look at the graph and the table. So I've done that just so I can make sure I'm looking at which data were included, and that's where I saw, oh, haha, they eliminated the 4th set of data, which is the effect of the sugar on the salt. So I'm going to stick it with the 3, oops, that's what I want. I want it all on one graph, but all the data. You don't want to have separate graphs because that makes it a lot harder to do your comparisons. Don't I'm going to do that. There should be. You can copy the graph and then you'd be able to paste that into your lab notebook, because you do need to include the graph so that I could see that you did actually look at the graph and you use the program to get the data. Let's go back here. And so there's your table 1. The table 2 for the rate of diffusion, which is that slope for the 1, 5, and 10%. And the table 3, I will eliminate the table 4 because you don't need that. So record all of your data. And I will also put a point in here for you to paste in your graph. You do need to include the graph in your lab report. And then there's the post-lab assignment. Asking about the conclusions you can determine. And we can't do table 4. But again, make sure that your answers are not just typed in the same font, but are made texturally somehow distinct from the questions. And as with all of the labs throughout the semester, there will be the submitting, and I don't get the pull down because I am the professor. Well, I don't think it gives me the option. No, I don't get the option to do submit because I am this professor. So I do need to go back in and eliminate that table 4 and put a big highlight, put your graph here, so that you know where you need to include the image of your graph. This Vernier graphical analysis will be used for other labs throughout the semester, not for the chromatography, but definitely for the spectrophotometry lab and a couple of others. So it's good to start early in the week, kind of figuring out how that program works so that you're not scrambling to do your analysis on Thursday.